record. I guess I'll record the review. And here's our final exam review. I am just going to grab problems that I think are going to be the most important. Some of them I won't even do, like a problem, and I'm just throwing this out there, like a problem like this, like 348 plus 123. This is a problem that normally I wouldn't review because I think we already know how to do this pretty well. All right. Now that I wrote it, I might as well finish it. So 8 and 3 is going to be 11. Carry the 1. 1 and 4 is 5 plus 2 is 7. 3 and 1 is 4. So the answer is 471. All right. I think we know how to do that. What I'm really concerned with is I want to review things like fractions. I want to review decimals. I want to review signed numbers. I want to review ratios and proportions for one of my favorite students, Alyssa, out there, because I know she had some problems with that. So that's the stuff I want to go over. All right. So here we go. First review problem. And I'm going to be asking a lot of questions. So make sure that you talk. You talk to me. You answer my questions. That way you get a better understanding of what's going on. So all we're going to do is add 7 over 12 plus 7 over 15. So first question, how do I do this? I'm adding two fractions. What do I need to be concerned with first? And I'm just going to throw this out there. For those who participate, you will get the most out of this class. So, how do I do this?
Don't you have to find the least common multiple?
Perfect. Got to find a least common multiple. So, step 1, let's go ahead and reduce the 12. We're going to prime factorize. 2 times 2 times 3. 15. 3 times 5. So, my least common multiple is going to be the product of unique factors here. All right. So it's the product of unique factors. So that's going to be 2 times 3 times 5. And now I need to find the exponents. So I look at each factorization. For the 2, the number 12 has 2 times 2. So that is the most number of 2's that I see in one factorization. So 2 to the second. For the number 3, the 12 has 1 3. The 15 has 1 3, so there's only 1 3. And then the 5 is only in the 15, so that's going to be a 1 5 as well. So my least common multiple is going to be 4 times 3, which is 12, and 12 times 5 is 60. So there's my first step. My second step, I'm going to go ahead and build those equivalent fractions. In other words, I need to multiply 7 over 12 by a very fancy way of writing the number 1, okay? So I need to multiply 7 over 12 so that I get a denominator of 60. The easiest way for me to tell you, or the easiest way for me to kind of push you in the right direction, what number times 12 gives you 60? And that's going to be 5. So since your denominator is 5, your numerator is 5, which means the equivalent fraction is going to be 35 over 60. Now, I'm going to do the same thing for 7 over 15. I want to build an equivalent fraction. So what number times 15 gives me 60? Well, that's going to be 4. So numerator is going to be 4, denominator is 4. 7 times 4 is 28. So I will take my equivalent fractions and I'm going to add them together, which is step 3. 35 over 60 plus 28 over 60. I always will write the denominator and then just write one numerator. And then I just add them. So I'll come over here to the right. 35, come on, plus 28. 5 and 3 is what? 13. Carry the 1. 3 and 2 is 5 plus 1 is 6. So we get 63 over 60. And we always want to make sure that our answer is reduced, correct? Yes or no?
Correct.
All right. So the question becomes, can 63 over 60 be reduced?
I believe by 3 on each, both.
I like it. So 3 times 21 is 63. Would you agree, Matt?
Yes, sir.
And 3 times 20 is 60. I can see that the 3's reduce. So I get an initial final result of 21 over 20. Now, the thing that we do have to be careful is, how do they want us to write the answer? What type of fraction is 21 over 20?
Improper fraction.
Improper. How do I make an improper fraction into a mixed number?
If you divide the two.
Perfect. So all we do is just divide. So the denominator goes on the outside, numerator goes on the inside, and you just divide. 20 goes into 21 one time. So I just subtract, and I get a remainder. Remember, your quotient is your whole number. Your remainder is the numerator. Your divisor is your denominator. So 21 over 20 equals 1 and 1/20 as a mixed number. So first question right off the start, I think, is an excellent question. You would definitely see that on the final. Before we move on, do you have any questions for me? All right, let's do the next one. I'd like you to subtract 93.42 and 57.69. So first, we have decimals. How do we subtract or add decimals? How do we add or subtract decimals? What's the key?
Making sure the decimals are aligned.
Perfect. Love it. So we're going to align the decimals. We're going to write nice and large and neat. I know my answer is going to have a decimal, which is in line with everything else. So now that I got everything set up, all I got to do is just subtract. All right, so 2 minus 9, I need to borrow. So that turns into a 12. 12 minus 9 is 3. Now I go over to the tens position. 3 minus 6, I need to borrow. So 13 minus 6 is 7. Now I move over to, I said the tens position. I'm in the tenths position. Now I move over to the whole, or to the ones position. 2 minus 7, I can't do. I need to borrow. 12 minus 7, 5. And then lastly, 8 minus 5 is 3. So I get a final result of 35.73. Any questions there? All right. Next example. I want to add 78.32 plus 4.089 plus 0.139. So once again, we're going to do exactly what Matt suggested earlier. We're going to align our decimals. Write nice and large. Make sure everything is nice and organized. Now here's a situation where I do have some gaps. So what I'll do is I'll just throw in some zeros. That way everything is nice and neat, organized. There's no missing gaps or anything like that. And then we just add straight down. 9 plus 9 is 18. Carry the 1. That's going to be 14. Carry the 1. We got 4 and 1 is 5. So, and we got our decimal point. Now for the whole numbers, 8 and 4 is 12. And 1 plus 7 is 8. So 82.548. How are we looking so far? Pretty good? All right, let's stick with this theme. And the theme is decimals. I'd like you to divide 23.764 divided by 0.62. Round to the nearest hundredth. Okay? So how do I divide decimals? Somebody other than CJ and Matt for now. Like, help me out here.
2 decimal places to the right.
Good. Jess, did I email you back?
I think so. I didn't check that.
Okay. So I need to make this outside number, the divisor. I need to make this a whole number. Which means I need to move the decimal place 2 places to the right. Now, if I move the whole number, if I move the divisor 2 places to the right, I have to do the same thing with the dividend. So here, I'm going to rewrite the problem. I'm going to place my decimal in the proper position. And then I'm going to place that decimal directly above in the quotient. Now I no longer have to worry about decimals. In other words, the decimal placement is done. So from here, all I got to do is divide. 62 does not go into 2. It does not go into 23. But it definitely goes into 237 3 times. So 3 times 62. My 8s have been looking a little sideways today. I don't know why. So 3 times 62 is 186. Now I just subtract 7 minus 6 is 1. I got to borrow. 13 minus 8 is 5. Drop down to 6. Process repeats. So 62 goes into 516. 8 times. 8 times 62 is 496. I will subtract. 6 minus 6 is 0. I need to borrow. 11 minus 9 is 2. Drop down to 4. Process repeats. 62 goes into 204 3 times. So that's going to be 186. So I just subtract again. So 204 minus 186 is going to be 18. Now, I have no more numbers to drop down. However, I need to round to the nearest hundredth. So since I need to round to the nearest hundredth, how many decimal places do I actually need?
Two.
I need more than 2. Because remember, right now, CJ, here's where we are. That's where we're standing. So I need how many decimal places?
Well, 3.
I need a total of 3. So maybe I misunderstood you when I said how many do I need? How many do I need? Maybe you meant 2 more, like a 2 additional. Is that what you meant?
I'll say yeah, but no.
Well, I'm gonna go with the yes and say that you were right and I was incorrect by thinking that way. So we need an additional 2 places. So what am I gonna do? I'm gonna put a 0 and drop down to 0. And I'm going to keep doing that until I get my 2 additional decimal places. So 62 goes into 180. I think that's what, 2 times? What is 62 times 2? I just lost my train of thought. 124. 10 minus 4 is 6. 7 minus 2 is 5. Drop down to 0 one more time. 62 goes into 560. 9 times. Now, I can stop here. I don't have to worry about what's 9 times 62. I don't care about that. I got my 2 additional places. So I'm just going to write the solution. Underline the hundredths position and look to the right. And I'm going to increase the number 2 by 1 because the number to the right of the underlying place value is 5 or greater. All right. So we get a final result of 38 and 33 hundredths. Are there any questions? Any questions whatsoever? All right. Let's go back to fractions. We're going to do a lot of fraction work now. (15/16) divided by 5/8. How do I divide fractions? How do I divide fractions?
You flip it, and then it converts it to the multiplication sign.
Okay, question. What do I flip? What do I write?
So beneath what you already have written down, you're going to flip the 15/16 to 16/15.
Oh, be careful. I am not going to flip that one. Remember, I rewrite the first fraction.
You flip the 5/8 to 8/5.
There you go. I reciprocate or flip the second fraction, and I multiply. I change division to multiplication. Okay? Are there any questions there? Now, before I multiply, I will simplify everything first. So here's what I'm going to do. The first fraction, 15/16, that 15, I'm going to rewrite it as 3 times 5. The denominator, 16. Now, I can write 4 times 4 if I want, but I'm going to be smarter than that. I'm going to write 2 times 8. And the reason being is, if you look at the second fraction, I have an 8 in the numerator, so I'm going to leave it like that. And in the second fraction, the denominator is a 5. Well, that's nothing more than a prime number. That can't be reduced any further. And the only thing I'm going to do before I start simplifying everything is I'm just going to write one big numerator with all the numbers in order being multiplied. And I'll do the same in the denominator as well. From here, I can go ahead and reduce. All right? I see a 5 in the numerator, 5 in the denominator. So they reduce. I see an 8 in the numerator, 8 in the denominator, and they reduce. to leave me with 3/2 or 1 1/2 as a mixed number. Okay? Are there any questions there? Okay, quiet today. Next problem. How about 3 5/7 times 35? Good, you try that. Yes, Alyssa.
Will this lesson be posted to the YouTube video?
Yes, it will, Alyssa. Does that help?
Yeah.
Okay. All right, did anybody get an answer yet? All right, I'll wait a minute. All right. Did anybody get an answer yet?
130.
130. I have no idea if that's correct because I didn't do the problem, but I'm going to write it off to the right. So, what is the one thing that we noticed about this problem that we really can't just multiply from left to right yet?
We have a mixed fraction and then a whole number.
Good, we got a mixed fraction and a whole number. So I need to take this mixed fraction right here and convert it into an improper fraction first. So off to the right, remember, it's going to be the whole number times the denominator plus the numerator, all divided by the original denominator. So 3 times 7 is 21, plus 5 is 26 over 7. So 26 over 7 times 35 over 1. Now, before I even go multiply, what I'm going to do is I'm going to simplify the 35. And the reason why is because I know 7 is a multiple of 35. Write that 7 a little neater. All right. From here, I could see that the 7s reduce. And I'm just left over with 26 times 5. So off to the right, 26 times 5. 6 times 5 is 30. 5 times 2 is 10. Plus 3 more is 13. So who gave me 130? Was that you, Jess?
Yeah.
Good job. Thank you very much. Any questions so far? All right. We're going to still stick with the fraction theme. What's another one we could do? Oh, here's a good one. How about 21 minus 13 and 11/15? How would we go about that? I think first things first, let's identify the types of numbers. 21 is a whole number. 13 and 11/15, that's a mixed fraction or a mixed number. So anytime I see mixed fractions and mixed numbers and I'm adding or subtracting, I like to stack them. Now, technically, I have a mixed number with the 21. It's just 0/15. All right? Now, I know the way it looks, I can't subtract. Because 0 minus 11, I can't do that. So I need to borrow. So that 21 is going to become 20. And just so I know we're all on the same page, when I borrowed from the 21 and it became 20, how many did I borrow? How many did I borrow? That's a good question.
Would it be 15?
And why would you say that?
Because you took one whole number away from 21.
Good. And that one whole number, in this case, is 15/15. Remember, when you're borrowing with mixed numbers, look at the denominator. That will tell you how many you're actually going to borrow. So now we have 20 and 15/15 minus 13 and 11/15. Denominator's the same. I can go ahead and subtract. 15 minus 11 is 4/15. And 20 minus 13 is 7. You always want to make sure that your fractions are reduced. In this case, it is. All right. So I did one. Now you get to do one. I want you to go ahead and do 9 and 11/15 plus 5/6. I'm going to go ahead and sit down for a little bit. I've taught this entire semester standing up. I think I'm going to sit down. Got my desk lowered. So what do I do? I mean, first thing I would do is stack them on top of each other. That's what I would do. So, 9 and 11/15 plus 5/6. Now, I know I can't add them. I need a common denominator. So I know I'm going to build some equivalent fractions. So off to the right, I'm going to find that LCM. 15 we know is 3 times 5. 6 is 2 times 3. So my LCM is going to be the unique product, or I'm sorry, the product of unique factors, 2 times 3 times 5, which is going to be 60. No, bad math, 30. Sorry, bad math. So I'm going to multiply each one of these fractions so that I get, let me put that out front, 30 as my denominator. So I multiply the top fraction, 9/11/15 by 2 over 2. So that's going to give me 9 and 22 over 30. The bottom fraction, I need to multiply by 5 over 5. So that's going to give me 25 over 30. Now, denominators are the same. So I'm going to go ahead and add. I get 22 plus 25, which is 47 over 30. However, I know I'm not done here because mixed numbers or mixed fractions always have the form a whole number plus a proper fraction. And right now I have an improper fraction. So what I'm going to do is I'm going to separate that 47 over 30. I'm going to separate that into 9 plus 30 over 30 plus 17 over 30. Does that make sense, everybody, what I just did? Like I'm telling you, you're going to see this on the final. All right, so here's what I did. The 47 over 30 is an improper fraction. So what I did is I said, okay, well, I'm going to make a whole. I'm going to make 1. And how do I make 1? Well, I look at my denominator, and since it was 30, I'm going to make it 30 over 30. Okay? What was ever left over, in this case it was 17, I just write on the tail end. So now this is going to be 9 plus 1 plus 17 over 30, or 10 and 17 over 30 as a final answer. Galileo, please don't chew wires. No chewing wires. All right, are there any questions there? Yes, no, maybe so. I mean, there's a lot going on in that problem. All right, I'm going to give you one to do now, which is kind of like this. All right, that's what I want you to do. 14 3/5 minus 11/15. Okay, who got an answer? Anybody? Come on, somebody got something, right? It's okay. I mean, we're learning this. So if you didn't get it right, you didn't get it right. Who cares? All right, I'll wait a little bit longer. Hey, easy, easy. All right, what'd you get? Still nothing. Am I all alone here?
Oh, okay, there we go. I have 13 and 13 over 15.
I like it. It's correct. Good job. Now let's see how to do it. First, I stack things up. I just like doing that because I have mixed numbers. It's a little bit easier for me to see. Next, in order for me to subtract, I need a common denominator. Now, this one's kind of easy. 15 and 5. 5 is a multiple of 15. So I don't have to go through all that, you know, creating equivalent fractions and everything and finding the LCM. I mean, I can go directly into this. So I get 9 over 15 minus 11 over 15. Okay? Now, come on, Galileo. Now, here's the thing, though. When I go to subtract, now that my denominators are the same, I can subtract the numerators. The problem is I need to borrow. Okay? I already have 9 to begin with. So what I'm going to do is scratch out the 14 and borrow from it. So the 14 comes to 13. And you got to remember, you started with 9 and you borrowed 15 more. So I'm also going to scratch out the 9. And 13 plus 9 is how much? $13 plus 9 is 22. Listen, this will go so much easier if we communicate a little bit. Okay? Somebody other than Matt and CJ. That's all I'm asking. So 22 minus 11 is what? No, that's wrong. See? You got me all worked up now. I have 9. I'm borrowing 15. Hold on one sec. I'm sorry. He is all over me right now. Now I remembered why I teach standing up. As soon as I sit down, he just wants to be on my lap. Or he's up in my face. So, recap. Now he's stepping on the keyboard. So, I have 14 and 9 15s. I need to borrow. Scratch this out. That becomes a 13. I already have 9. I'm borrowing 15 more. So I have 24. Now I can subtract. 24 minus 11 is 13. Denominator stays the same at 15. And 13 minus 0 is 13. All right. Sorry about all that. Ever since we got ever since we got Artie, he's become a little bit more affectionate. So I think he's like getting jealous. And now that Artie's upstairs taking a nap, Galileo's like, oh, I'm going to get some loving in. All right. Any questions with this? Okay. We're still going to stick with the theme of fractions, except we're going to switch it up a little bit. We're going to talk about ratios. So remember, a ratio is a fraction of two quantities. For example, 3 to 5. Like, that's an example of a ratio. Now, I can write that as a fraction if I wanted to. Okay? I can also write it like this, with that colon in between. But the idea is a ratio is a fraction of two quantities. Okay? Now, a proportion is when you have two ratios equal to each other. Now, since I'm hungry, I'm going to go with this example. A survey at a McDonald's showed that 27 of 50 customers asked for a Big Mac. I'm a huge fan of a Big Mac. I don't know about you. I really like them. I like the special sauce. I think it's like Thousand Island dressing. But it's really good. First thing we're going to do is write the ratio of Big Mac served to total customers. Okay, so that's the first thing we're going to do. We're going to do a couple things with this problem. So, once again, a ratio is a fraction of two quantities. The two quantities I'm concerned with are Big Mac served and total customers. So, that's going to be 27 over 50. Now, if you wanted to get really, really technical, you would write the units. Okay? Are there any questions with how did I form that ratio? All right. Now the next thing then would be, well, this is part A. Part B. What is this percentage? So how do I actually find the percent of this? 27 over 50. So how do I find a percentage if I'm given a fraction? So how do I convert a fraction into a percent? That's the question I'm really asking here. So how do I do that?
Put it over 100.
Say that again.
Put it over 100.
Put what over 100?
2750.
So you're saying do this. Because that's putting it over 100. And I don't agree with that.
Don't you divide the numerator and the denominator?
You divide first. Good. So, let me ask you this question then, Matt. If we divide the denominator into the numerator, what are we actually creating? Like, what type of number, I think is a better way to ask it. So, if I divide 27 over 50, what type of number do I create?
I think a mixed number.
Not a mixed number.
Or a, sorry, darn, I know the answer to this, and I can't get it up. I can't say it properly right now.
Would it help if I gave you a hint?
Wouldn't it turn it into a decimal?
There it is. So the first thing we need to do, in other words, when you go from a fraction to a percent, you need to go from a fraction into a decimal and then the decimal into the percent. The decimal into the percent is easy. It's going from the fraction to a decimal that makes it difficult. So I just divide. 50 does not go into 27 at all. So I put a decimal and a decimal, write a 0. Now, 50 definitely goes into 27. Or, I'm sorry, 270. How many times? Five? You think 5 is good enough? I mean, think about it. 27 over 50 is really close to 25 over 50. And 25 over 50 is 1/2. That's 50%.
I was reading that as 170 for some weird reason. I don't know why.
That's okay. I do it all the time. Don't worry. So 50 goes into 270 5 times. So 5 times 50 is 250. I will subtract. So I get a 0. I get a 2. I put a 0 and drop it down. Now, 5 goes into 200. Or I'm sorry, 50 goes into 200 exactly 4 times. And that's a good thing. So what we've done is we've taken 27 over 50. We converted it into a decimal. So 27 over 50 equals 0.54. And we know if we want to go ahead and make a decimal into a percent, we multiply by 100 and just add that percent symbol onto it. So 54% of customers are served a Big Mac. And like I said, I like Big Macs. They actually made a Big Mac with like the quarter pounder meat, like the bigger meat. I was like, whoa, now we're talking. So, are there any questions? All right, so what we did is a ratio problem. Then we went ahead and converted from a fraction to a decimal, which we had to go into a percent. I'm sorry, so we went from a fraction to a percent. I think it's really good if we do a problem like this now. A certain drug is to be administered at, let's say, 20 cc's for every 5 pounds. If someone weighs 140 pounds, how much of this drug should the person receive? Okay? So when we look at a problem like this, notice we're still comparing quantities. We have cc's for every 5 pounds. And that's the thing you got to be able to recognize, is that you're comparing these quantities here. So that's a ratio. Anytime you're comparing quantities, it's a ratio. So I'm going to write 20 cc's over 5 pounds. Now the question becomes, if somebody weighs 140 pounds, how much medicine or how much of this drug should they get? So there's another comparison. And what I'm going to do is, because I notice I have a ratio in the first sentence and a ratio in the second sentence, I'm going to set them equal to each other, which is a proportion. And anytime I write a fraction equal to a fraction, I need to guarantee that the units match each other. So I'm going to have cc's in the numerator and then pounds in the denominator. The thing that I don't know in this second ratio, I don't know how many cc's of the drug I need to give, but what I do know is this person weighs 140 pounds. Now, if we just extract only the numbers, what we're going to have is 20 over 5 equals x over 140. Even better, I can see that I can totally simplify that first ratio, that 20 over 5. That can simplify down into 4 over 1 equals x over 140. I got the 4 over 1 because 20 is really 5 times 4. And the 5's reduce. And if everything reduces in that denominator, it turns into a 1. So that's how I got the 4 over 1. Now the question becomes, how do I solve this problem? Well, when you have proportions, how do we solve them? It's the only time you're allowed to do this. Perfect. So we're just going to cross multiply here. So 4 times 140 equals 1 times x. Now, what's great is on the right-hand side, 1 times x is just x. So the only thing you got to do is actually multiply 140 times 4. And that gives you 560. So the 140-pound person should get 560 cc's. Does that make sense, everybody? Are there any questions? Are there any questions? None whatsoever. All right, so I think what we should do is we're going to end this class with some order of operation problems. Okay? I think order of operation problems are always really, really good problems. Actually, I'm just going to write this. Simplify the following. All right, we'll start off a little easy, then we'll get difficult. Excuse me. 11 minus 3 plus 9 minus 6. So before we even dive down into this, let's make sure we remember our order of operations. What are they?
Parentheses, exponents, multiplication and division, left to right, addition and subtraction, left to right.
Alyssa, that was excellent. So just give me a second here. I'm going to write it. So we do parentheses first, exponents second, and then multiplication and division. You could do them at the same time, however you do them left to right in the order they appear. Same thing with addition and subtraction. So for us, in this example, I see parentheses. So I need to go ahead and subtract 11 minus 3 first. And I'm going to do 9 minus 6 as well. Now, I'm left over with 8 plus 3, which is 11. Alex, did you steal my cat? You're muted. You are still muted.
No, this is my sister's cat that she decided to leave.
Look at that beautiful black cat. What color are his eyes? Are they yellow? Oh, he just took off.
They're like a little bit orange yellow.
It's exactly like Galileo.
The nuisance.
Oh, come on, it's a cat. Of course it's a nuisance, and they're great. If you lay Galileo, if I hold Galileo like a baby, on his belly he has like maybe 15 little white individual hairs, and that's it. That's the only white on his whole body. So it's
Anytime my old cat goes to he goes out of Daxter.
They'll get along eventually.
Yeah.
All right, next problem. All right, so we have -7 times 12 divided by -6. What is the first thing that I need to do here?
Multiplication.
I got it.
7 and 12.
Excellent, CJ. I got to do the multiplication first. Because remember, parentheses first, exponents second. I don't have any of those here. Multiplication and division from left to right in the order they appear. So -7 times 12 is going to be -84. Now, I can go ahead and divide. A negative divided by a negative is a positive. That's the easy part. 84 divided by 6 is 14. Any questions there? Remember, if you just take your time, you think about the order of operations, you remember all those little things from the entire semester, like sign numbers. We have rules for adding and subtracting. We also have rules for multiplying and dividing. If you remember those things, this will be easy, okay? All you gotta do, I think the most important thing is just to write neat and take your time. Next problem. Six squared minus 4 squared. Go ahead and do that. What'd you get?
20.
Oh, I love it. 20 is the correct answer. Let's understand why. 6 to the second power is 36. 4 to the second power is 16. So you do the exponents first. Now, 36 minus 16 is 20. And there is one thing that actually happened in this problem, and you might not even have noticed what happened. And here's what it is. We got to remember the difference between these two examples on the right-hand side of your screen. There's a difference there. The first example, that is -4. Listen to even the way I say it. -4 to the second power. The second example is the quantity -4 to the second power. There's a difference there. So here's the difference. That first one, that is really -1 times 4 to the second power. And remember, if that's the situation, the only thing that is being raised to the second power is the 4, not the negative symbol. So this becomes -1 times 16, or just -16. In the second example, the quantity -4 squared, that means that both the negative and the 4, I'm going to rewrite it twice. A negative times a negative is a positive. 4 times 4 is 16. So make sure, I think I shut it off, yeah. Make sure you understand the difference between those two. Okay? Because I know there's going to be at least one person in this room that sees this right here. They see that negative symbol in front of the 4, and they see the 4 is raised to the second power, and they will actually write 36 plus 20, which is wrong. I'm telling you, one person's going to do it. Maybe two. And that's what I meant by something happened in this problem and you probably didn't even notice it. And that's what it was. Okay? All right, let's do some more. Oh, come on. All right, so we have the quantity 10 minus 15 times the quantity -4 minus 3 plus the quantity 12 minus 7 times the quantity 3 plus 2. So a lot of sets of parentheses. What's really nice about this, we can do all the work inside the parentheses for each set of parentheses at the same time. So the 10 minus 15 is -5. The -4 minus 3 is -7. And if you noticed, I kept them in parentheses. And the reason why I did that is because if you go back and you read the original problem, the quantity of 10 minus 15 and then the quantity of -4 minus 3, those two quantities, whatever they happen to be, are being multiplied. So by me preserving the parentheses, I'm still showing multiplication. I'm going to do the same thing on the right-hand side. 12 minus 7 is 5. 3 plus 2 is 5. So from here, I can go ahead and just do my multiplication now. Negative 5 times negative 7 is positive 35. Plus 5 times 5 is 25. Off to the right, I'm just going to add these two numbers together to give me 60. Are there any questions?
Mr. Flip,
Yeah, do I have a mistake somewhere?
3 plus 2 is 6, not 5.
Are you sure?
Yes.
Positive.
Or, I'm thinking 3 times 2.
Exactly.
Or I'm thinking of 3 times 2.
Robert, if I had a nickel for every time I did that, I'd probably have $100. Not everybody's perfect. I make mistakes too. In fact, I made a mistake earlier today. One thing I don't do, though, is let it bog me down. All right, let's do 2 more problems and we'll call it a day. Okay? All right, these are going to be more difficult order of operation problems, but we can handle them. I got to make sure I write nice and neat here. So I'm like taking my time. All right. So the first things first, while you're copying it down. What is the purpose of brackets? What is the purpose of the brackets?
Doesn't it show where you need to start first from left to right?
I'll buy that, but there's a better answer. I like it, but it's a little bit more than that. So I'll buy it, but I definitely want some more. I mean, I guess, how come I didn't use parentheses? Why did I choose to use brackets? Do the brackets change the problem at all?
The fact that it makes you have to focus on a group of a set of numbers rather than parentheses would, because without them, you could essentially do the problem differently.
So, to be honest with you, CJ, the brackets, the only thing they do is they just serve as an easier way for my eyes to focus on the problem. The brackets don't change anything. It just makes the problem a little bit easier for me to focus on, to actually read. Galileo, please go back here. Good boy. That's the only thing they do. Like, I could, if I wanted to, I can use parentheses all over the place. But the problem is, it starts to get messy looking. So we just use brackets just to clean things up. So I'm still going to do the work inside of the brackets. That's not an issue. I treat them as their parentheses. So let's go ahead, let's simplify this inside first on the left of the plus sign. So I look at the inside, and I have, oh, that's a really good thing. You know what? I'm going to let you do it. Now that I'm looking at it. Just what I have underlined here, go ahead and simplify that for me. I want to make sure we're getting the correct answers. Because that's really good. All right, what do we get inside the parentheses? What did you get inside the parentheses? Here's what I got. I got a 9. Anybody else get 9?
That's what I got.
Good, Robert. So let's...
I got 9.
Perfect, Matt. So let's see how we do this, okay? What I'm going to do is just draw a line, and I'm going to write the inside of those brackets off to the right here. Now, first things first. I know a lot of us may see the double negative back to back, okay? You need to be careful. You do not do that first, okay? That is a multiplication thing. You got to do the exponent. So, -5 times -9 minus -6. The quantity of -6 to the second power is 36. Now I'm going to do -5 times -9, which is 45. And 45 minus 36 is 9. So this entire inside of the brackets turns out to be a 9. And I still have to raise that to the second power. Plus. Now I'm going to do the same thing here. I'm just going to rewrite inside the brackets. Now this is a little bit easier for us. We need to do the exponents first. -1 to the third power is still -1. Now a negative times a negative is a positive. 8 plus 2, which is 10. And that is still raised to the second power also. So 9 to the second, 81, plus 10 to the second is 100. And 81 plus 100 is 181. All right. Are there any questions? All right. We'll just stop today. We'll